Hello everyone, welcome to Ganit Gurukul, and this is JEE Advanced 2015 Paper 2 question number 55. So we have a function fx which is a function of 10x if we see it carefully for all x belonging to minus pi by 2 to pi by 2, right? And obviously pi by 2 and minus pi by 2 they are not included. Then the correct option is or R is. So this is not a big question. It's just what we have to do. We have to do see either B or D should be correct and either A or C should be correct. So it's not that very difficult question, right? Now how to go about this? You have this B and D. What they are? Integral of fx dx from 0 to pi by 4. Right now fx. If you see this carefully, what we can do from first second term we can take 7 10 to the power 6 common, right? 7 10 10 10x to the power 6 common, and we will get inside of it 10 square x plus 1. Then from third and fourth take minus 3 10 square x common, so you will get 10 square x plus 1 again. Now if you again take 10 square x plus 1 common, you will get 7 10 10x to the power 6 minus 3 10 square x, right? And into 1 plus 10 square x, which is sec square x. Now what is the use of this? What is the utility of this? I hope I need not to tell what is the utility of this. If you integrate fx dx, this is nothing but 7 10 x to the power 6 minus 3 10 square x into sec square x dx. And I hope you must be very familiar with this thing, that if we replace 10x by t, sec square x is dt. So if we say 10x as t, put 10x is equal to t, then sec square x dx is equal to dt. Fine. So now it's very easy. 7t to the power 6 minus 3t square into dt. Integrate this, you will get 7t to the power 6 dt. Integrate this, you will get 7t to the power 7 upon 7. So this is t to the power 7 minus it will be t cube. But apply the limit 0 to pi by 4. And for here, if you have 10x is equal to t, limits will be 0 to 1. So it is fairly easy. What you can see, it is equal to 0. 1 minus 1, it will be equal to 0. So the answer to this first thing, answer to this particular thing, B or from B and among B and D, which is correct, B. Now x fx dx, this is also what we have to do, right? X fx dx, integrate this between 0 to pi by 4. Now how to do it? How to do this? So we have find integral of fx dx, right? That is t to the power 7 minus t cube. Now how to find integral of x fx dx? What should we do? So I recommend using eyelet while resolving this x fx dx, integrating this. I suggest using eyelet because it will make the process easier, right? Now x fx dx integral of this, it will be equal to how to go about this? Use this x integral of fx dx minus integral of derivative of x, that is 1, then integral of fx dx into dx, right? I hope you must be getting this. Now integral of fx dx, it will be equal to t to the power 7 minus t cube, and it will be in terms of x, it will be 10x to the power 7 minus 10x whole cube, right? This is integral of fx. So replace it. So this expression will be equal to, this is x 10 7x minus 10 cube x, right? Minus, now it will be a issue integrating this thing, 10x to the power 7 minus 10 cube x. Now this is a issue, a real issue. Now how to integrate this? Is it very difficult to resolve? No, not at all. It is difficult, but not very difficult. Why I am saying this? See, in just what we have to do, we have to integrate this, right? 10 in these two terms, what we can do, we can take 10 cube x common. We will get 10x to the power 4 minus 1, right? And it can be written as 10 cube x into, use a square minus b square, 10 square x minus 1 into 10 square plus 1. and our issue is resolved. It is resolved now because we can write this as 10 cube x into 10 square x minus 1 into sec square x. Now our job is done. We have to integrate this, and integrating this is easy. Put 10x is equal to t. So I am doing this thing for second integral, right? For this. So put 10x is equal to t. So this whole expression can be written as t cube into t square minus 1. And this sec square x dx will simply be dt into dt. We have to integrate this. This is t to the power 5 minus t cube dt. So that will be t to the power 6 by 6 minus t to the power 4 by 4. This will be its integral, right? But we have to write it in terms of 10x. So finally our expression will be, first term is x 10x to the power 7, right? So first is x into 10x to the power 7 minus second was x into 10x cube. So 10 cube x, basically x into 10 cube x. Then you have minus sign, minus and then t to the power 6, t is 10x, so 10 power 6 upon 6 plus 10x to the power 4 upon 4. But we have to put the limits as 0 to pi by 4, right? 0 to pi by 4. Put the limits as 0 to pi by 4. In this, put the limit 0 to pi by 4. So limits are 0 to pi by 4. Let us evaluate. Put pi by 4. So pi by 4 into x. X into pi. If you put replace 10x by, if you put pi by 4 in 10x, it will be equal to 1. So first term will be pi by 4 only, minus pi by 4 minus 1 by 6 plus 1 by 4. So this is the, if you replace pi by 4 as input, minus replacing 0 in terms of x, and it will be 0 only, right? So pi by 4 minus pi by 4 will get eliminated, minus 1 by 6 plus 1 by 4. If you evaluate this, it will be equal to 6 minus 4 in numerator upon 24 in denominator, which is 2 by 24. That is equal, 2 by 24 is equal to 1 by 12. 2 by 24 is equal to 1 by 12. So answer to this particular thing, integral x fx dx in 0 to pi by 4 is 1 by 12. So A is the correct option among A and B. Now again you must be wondering what is the utility of this question at this particular moment of time. I say it with pure conviction that this sort of question can appear in mains. Again, the only purpose or the only point which I raise over here is taking 10 square x plus 1 common, right? That's an interesting part of this question. Even asking this much, x fx dx in case of fx is this, is not a big deal. This sort of question can be asked, right? This much of integration is not difficult with respect to mains examination. If you see the papers of 2021, so this sort of question can be asked fairly I would say average category question, and this question can appear in mains examination. So I hope this video was clear to each and every one of you. So stay tuned, keep watching Garit Kulkul, and we will be back with more such videos.